Hi, it's time for the math. Easy solution. Here to discuss further into integrals and areas between curves and do part 3 of the example series. And I'll go over this example, which basically states the figure below shows velocity curves for two cars, A and B, that start side by side and move along a straight road. So just like a straight road like this. There's car A and car B. And then basically here's the curves given, and they both go here, and what we track is, as we just track the velocity of both of them. And then as you can see, the A one is a bit faster, so it would be a bit further apart later. So basically the question states, what does the area between these two curves represent? And use the midpoint rule to estimate it. So basically we want to know, what is this area representing right here? Well, like I showed in my earlier video, basically when we're dealing with velocity, the integral of velocity, that is distance, or in other words, the area under this curve, for example this B1, is the distance it travels. It's basically this distance right here. So it's distance. And also for A, the area under A is also distance. So the difference right here, so this area right here is basically the distance between A and B. A and B. Yeah, so now let's estimate this, basically this area between, or the distance between A and B, using the midpoint rule. And for this one, let's just use, so the midpoint rule is, like I showed in my earlier video on integrals, is you would basically, if you have a curve like this, you would find a point, and then you would move left and right, and then you would find another point like this in the center. So that's the midpoint, versus if you had the right side, is this would be a right hand rule. So that's right, and this is midpoint. Yeah, so in this example, let's just do, let's separate, basically let's try to estimate this area under, let's start with B first, estimate it under it with, let's say, n equals 4, or 4 blocks, or 4 basically summations. And what I mean by that is, let's just start, if we have it 4 like this, there's 16 seconds, so 16 divided by 4, we basically break up 16 seconds into 4 separate, that equals 4-second intervals. So we break it up into 4, so we go like this, there's 8, 12, 16, and in between 0 to 4, that's 2, so we go up here, there's a point, and then we just draw a rectangle like this. So this will be our estimation for under the B. And now for the midpoint, now we go to 6, and then do this, etc. So that's under there, and then go 10, and now we go to 14. So now all we do is sum up the area underneath this, and that is a rough estimate for the distance between, the distance that B travels. So this is just a rough estimate, but we want to know the difference. So if we just move this up like this, whoops, so we go up like this up to A. So now we do the same thing. So this difference between it, let's just keep going like this, and then like this, and then up to here. So now we have basically a rough estimate of what's underneath or in between areas A and B. This is now, so then this shaded area is the distance between A and B, and we can roughly estimate the size of these blocks, because we know that they're all going to be 4 seconds apart. Now the difference between these are, let's just do a rough estimate from this. This is about 63 minus, this is about 42 right here. That equals to 21. And now roughly this one right here, let's go like this. Yeah, I just quickly changed the color to yellow to make it easier to see. So this is about 57 minus 37 is 20, and remember the units is miles per hour. This is also miles per hour right there. And now this difference right here is roughly, let's go 30. So so we minus that. That's going to be from the top, which is about 45. So that's equals 15 miles per hour. And now this last one, which is like over here, that's about this roughly 15. That's going to be, let's say 21. So 21 minus 21 minus actually 13 right here equals about, this is 8. So we have these blocks right there. Yeah, so now all we have to do is add up all of these 4 blocks. So that's going to be, well, 8 miles an hour multiplied by 4 seconds. So this is 4 seconds. I'll just take that out of there, or I'll write it like this. Let's go plus. This go right here, 15. I'll add it at the end. 15 plus 20, and then plus, this is 21, and then all times by 4 seconds. So basically we're just summing up the area of all these rectangles, and when we do this we get, so we get basically, this is going to be 256, but again you have to make sure the units. So the units, we have miles per hour, and then this is times it by second. So again, we have to make this as a distance, so we have to convert basically seconds into hours, and also we'll convert miles to feet just to make it a bit easier. So we know that 1 mile equals 5280 feet, and 1 hour, that equals to, well, 60 seconds times 60 minutes. That's 300, and that's 3,600 seconds. So we add these conversion factors to the numbers. 256 miles times it by 1 mile. I mean, not 1 mile. We times it by 5,280 feet divided by 1 mile. So when we do this, these miles cancel. And now we times this by, well, we have seconds over hours. Now we have to multiply this by this factor, which is going to be 1 hour divided by 3,600 seconds. So this way the hours cancel. This is 1 hour. The seconds cancel, and all we're left with is feet. Actually, this feet right here. So then we put this in a calculator, we get about roughly 375 feet. And that is our answer. So this means basically that car A was basically further than car B by 375, or roughly 375 feet from the start. And we got this basically from this curve of velocities. Anyways, that's all for today. If you learned from this video, and basically, thanks for watching. Like always, you can download these exact notes in the link below, and thanks for watching, and stay tuned for another Math Easy solution.